In this lesson, we're going to look at two more ways to solve multiplication and division problems. The first way is using arrays to solve problems. And after that, we're going to look at using area models to solve problems. Let's look at our first question. A booth at the Florida State Fair in Tampa has 15 pies. There are 3 rows of pies with the same number of pies in each row. How many pies are there in each row? Let's start by making an array. Have you ever heard of an array? An array is an arrangement of the same number of objects arranged in rows. So let's look at our story here. It says that we have 15 pies. So let's count out 15 pies. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we've counted out 15 pies. It tells us that there are 3 rows of pies with the same number of pies in each row. So let's start by showing our 3 rows. 1, 2, 3 rows. So I'm going to continue arranging my 15 pies into 3 rows to form an array. Once I've built my array, I will be able to count to see how many pies there are in each row. Alright, I'm using up my last few pies here. I can see that I have 3 rows of pies, and I have 1, 2, 3, 4, 5 pies in each row. So I'm able to see here that there are 5 pies in each row. I was able to use an array to solve that problem. Now I can write that in words, and what I did was I did 15 divided by 3 because I put them into 3 rows, and I found out that there were 5 pies in each row. Now let's look at question B. A booth at the fair has pies in 3 rows with 5 pies in each row. How many pies are there in all? Well, I could start modeling this problem with an array by showing one row, and I'm going to show the 5 pies in each row. So I'm going to make one row first with 5 pies. 1, 2, 3, 4, 5. And then I can make 3 rows with 5 pies each. So I have my pies in 3 rows. I have 5 pies in each row. They want to know how many pies are there in all. Well, I can see that there's 5, 10, 15 pies in all. There are 15 pies in all. And I can show this with the multiplication sentence because I have 3 groups of 5, and that's going to give me 15 pies. So that's one way to solve problems to build an array. Another way to solve problems is using area models. The area is the number of squares that fit inside an object. Now let's look at question A. The fair has a treasure hunt map. The map is 6 squares long and 5 squares wide. How many squares are in the map? Well, I'm going to start by showing my map that is 6 squares long. 1, 2, 3, 4, 5, 6. Now I'm going to show the map being 5 squares wide. So I have 6 squares long. Right now it's only 2 squares wide. Now it's 3 squares wide. Now it's 4 squares wide. Now it's 5 squares wide. And my question is, how many squares are in the map? Well, I can count each square, or if I see that in each column I have 1, 2, 3, 4, 5 squares, I can count by 5s. 5, 10, 15, 20, 25, 30. So I can see here that there are 30 squares in the map. Now I can represent this with a multiplication problem because I have 6 groups of 5, and that gave me 30 squares. Here's one group of 5, there's another group of 5, 3 groups of 5, 4 groups of 5, 5 groups of 5, 6 groups of 5. So I can see here that 6 groups of 5 is 30, and so there are 30 squares in my map. Now let's look at question B. The fair has a treasure hunt map that covers 30 squares. The map is 5 squares wide. How many squares long is the map? Well, here I know that I need to start with 30 squares, so I'm going to count out 30. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now there's 10. If I need 30 squares, I can make 3 groups of 10. So that's 20, and that is 30. So I'm starting with 30 squares, and it tells me that the map is 5 squares wide. So I'm going to show it as 1, 2, 3, 4, 5 squares wide. They want to know how many squares long is the map. So I can continue to put my squares here to show the area of 30 squares. And then I can see how many squares wide my area will be.